This is Guns and Butter.
There's something happening, yeah. Yeah, yeah. What it is ain't exactly clear. There's a man with a gun over there.
Well, on October 29th, the only time our highest alert, which we call an alert star, we put a giant star on the map over the area, the only time an alert star of ours has ever appeared outside of the ring of fire, only happened once, was October 29th, 2016, and it was over the country of Italy. Many people know that on October 30th, just one day later, a 6.6 struck that area. It took down the Basilica of St. Benedict, and it was the largest earthquake that has hit there in decades and decades.
I'm Bonnie Faulkner. Today on Guns and Butter, Ben Davidson. Today's show, Space Weather and Earthquakes. Ben Davidson is an independent researcher into the science of climate change. One of his websites, suspiciousobservers.org, is an online research community investigating solar activity, earthquakes, earth changes, and weather. His website, earthchanges.org, is where you can find his new Disaster Predication app. His website, spaceweathernews.com, is where you will find the archive of his daily short Space News broadcast, aired every morning at 6 a.m. Eastern. He is the author of a new book, Weatherman's Guide to the Sun, Space Weather News. Today we discuss the sun's influence on the Earth, the influence of cosmic rays, geomagnetic storms, space weather's impact on human health, and the launch of the Earthquake Prediction Center. Ben Davidson, welcome to Guns and Butter again. It's been far too long since we've talked.
Absolutely. It was a pleasure last time. I do get a chance to keep in contact with some of our friends from the show quite a bit, but it has been too long since I've been here.
I can't wait to get caught up with your work with Suspicious Observers. You just published your second book titled Weatherman's Guide to the Sun, Space Weather News. You write that this book is primarily about the Earth-Sun relationship, and that one intent of your new book is to help the reader understand what to expect on Earth when certain things happen on the Sun. What topics do you cover in Weatherman's Guide to the Sun?
Well, both the short-term and long-term effects of certain solar phenomena on the Earth. And when I say on the Earth, I mean the weather, and on seismicity and other crustal action like volcanoes.
Could you talk about some of the important activities of the sun? And this covers a lot, including the solar wind, solar flares, coronal mass ejections, and coronal holes. When I was reading your book, I realized how important these coronal holes are. And then there's also something called interplanetary magnetic fields.
Right. Well, it could be a long and difficult audio-only discussion to try to teach about space weather and the different things that the sun does. But we can talk about them very generally. Real quick, if people want to learn more about this stuff, they can go to spaceweathernews.com, and right up at the top of the page in big bold letters, it'll say, "What is space weather?" with a question mark. If you click on that, there is a 1-hour tutorial that will literally get you to probably the 99th percentile in terms of understanding the sun among all people on the planet. But at a most basic level, there's a short-term and some long-term cycles on the sun. The short-term one is about 11 years, at least the important short-term one. And during this 11-year cycle, we go from low activity to high activity and back down again, and sort of like on a wave up and down. Now, what do I mean when I say low activity and high activity? Well, during the high activity, we get a lot of these sunspots, these dark-looking areas on the sun, and it turns out that even though they're darker, even though they're slightly cooler, they contain the powerful magnetic fields that create what are known as solar flares. They send X-rays out into the solar system. They can blast charged particles like protons, electrons, positrons, which is basically a hydrogen atom without the electron, blast those out into space, and those can have effects on the planets as well. On a minor level, when this happens, we get the auroras, the northern lights and the southern lights. But in more extreme examples, these can actually take out power. In 1989, the entire province of Quebec lost power. In 1859, an event called the Carrington event, for a man named Richard Carrington who studied it, took out what little there was technologically. Telegraph wires caught on fire, operators got shocked, they unplugged the machines, and yet telegraphs kept coming in on the wires even though they had allegedly unplugged the power. It's the kind of thing that, if it happened again today, could produce a global blackout that not only it's like the kind of thing where they have to go flip the breaker back on, but literally the global power grid could actually melt down from something like this. And it happens once every few hundred years. Humans have survived this many, many times throughout the past. It just sort of looked like beautiful lights in the sky, but now that we have an electrically dependent way of life for the most part, we are in a new realm of vulnerability. And the last time the sun did this was sort of at the dawn of our entrance into the electric age. And so, it could be tomorrow. It could be, 100 years from now. We're really not sure. Back in 2012, there was a blast that was about that big that actually missed us by about 3 months in our orbit. So if we had been 3 months ahead around the sun, it would have hit us. And we've gotten lucky a few other times as well. But we're actually starting to notice that the sun's activities have more than just those super obvious connections. These rare events happen on the sun, and we get the expected rare electrical events on the Earth. Well, electricity has a lot more to do with the weather and earthquakes than has been realized over time. And as Earth's magnetic field, a lot of people don't know this, Earth's magnetic field is weakening as the magnetic poles are actually beginning to move and shift. That is allowing electricity to play an even larger role in all of these things on our planet, and that even includes human health. So really a lot of topics, a lot of different ways to go from there, but essentially what the sun does is it puts out electromagnetic waves, electromagnetic particles. It has interplanetary magnetic fields that directly connect to the planets. And Earth is riding in the sun's magnetic field in an electric field of particles known as the solar wind. So this is really an electrical thing we're talking about. And the only interface we have, the only thing blocking out all of this energy from space, is Earth's magnetic field, our magnetosphere. So as this weakens, naturally, the electricity is going to play a lot greater role. Many folks have been studying the over-ionization of certain levels of the ionosphere. Any ham radio operators out there who have been noticing that the critical frequency of the F1 layer has been much, much higher than expected. This is one of the effects. Things aren't always that obvious when you're talking about the weather and earthquakes, but when you start to be able to focus on certain phenomena, not just look at, the sun's doing all of these things, but when you pick out just one specific thing, and when you can narrow down some of these things, earthquakes become predictable. Short-term, mid-range, and long-term climate becomes much more predictable. And that's really the age we're sort of entering right now. And it's very interesting that we're entering that age of understanding the Earth-Sun relationship at a time when the Earth-Sun relationship is about to go through a bit of a tiff, so to speak.
In reading your book, I came away with the impression that there are, to simplify matters, two opposing forces at work in our solar system with regard to space weather: the activity of our sun, including the solar wind on the one hand, and cosmic rays, including X-rays, gamma rays, and interstellar particles on the other, and that the activity of our sun protects us from these cosmic rays which come in from other galaxies and supernovas, etc. Is this an oversimplification?
Well, if you are trying to get a dissertation in plasma physics of the sun, probably. However, you very adequately described how this works. Whether we're talking about the magnetic field of Earth, the magnetic field of the sun, the solar wind, the energy of a solar flare, or we're talking about the galactic cosmic rays that are bombarding our solar system, we're always talking about, I should say we're almost always talking about electromagnetic particles. In galactic cosmic rays, there is some neutron involvement, but the majority of the modulation of these galactic cosmic rays, how much gets into the inner solar system, how much gets into the Earth versus how much is blocked, is based on two systems. Earth has two shields against this. One is Earth's own magnetic shield, our own magnetic field, the magnetosphere, but the other is the sun's. The sun's magnetic field sort of balloons out and gets much stronger when it's got that high activity with the sunspots and the solar flares. And then during the low periods, it sort of shrinks back down and becomes weaker, and we notice a lot more cosmic rays are able to bombard the inner solar system during those times. And so the sun modulates what is able to get into the inner system, and then Earth has its own shield that sort of has to, block what has managed to get its way in there.
In most media, you only hear the two sides to climate change. Either you believe that man is responsible for global warming, now renamed climate change, or you are on the other side denying that the climate is changing. You have a different view that there are other factors outside of the climate system on our planet that impact our weather and even climatic changes. Can you describe some of these factors?
Well, absolutely I can. And I'd first like to say that I've done a good job coming along and putting together a lot of information and communicating that hypothesis. But this is not something new. The fact that there might be a third avenue that Earth might take down into the future. Folks like Landscheid, who was first predicting decades and decades ago that we were going to go into a mini ice age at some point, within the coming decades, the coming 2 or 3 decades or so. But there have been a lot of folks who have been talking about this for a long time. And essentially, for whatever reason they think, a lot of times it has to come down to the sun. And I happen to agree with that. And there's a caveat this time that the wild card is that Earth's magnetic field is changing as well. At no point have we experienced what we're experiencing with Earth's magnetic field at this point. It has basically been at very, very high levels of strength for thousands and thousands of years. And yet in the last about 150 years or so, we've lost about 20% of the strength of the magnetic field. And so that's really the wild card in a lot of what we are seeing right now.
I'm speaking with independent researcher and author Ben Davidson. Today's show, Space Weather and Earthquakes. I'm Bonnie Faulkner. This is Guns and Butter. You write that in 2013, it began to become clear to the world that we were approaching 20 years of vastly overestimated global warming predictions. The official predictions of record have been able to predict the extremes of climate change, with the exception of perhaps the most important piece, global warming. Could you talk about these 20 years and what has occurred with the climate?
Well, absolutely. We've had this thing that's called the global warming pause, and you can find some scientists trying to argue that it hasn't really been a pause. At first, they tried to say the oceans ate the heat. That got sort of debunked. They're trying to say that for another reason now. At one point, they tried to say that a lot of the heat went down and was melting part of Antarctica, and then the University of Texas discovered that one of the largest erupting submarine volcanoes ever discovered is erupting right underneath where the ice is melting. And so there's a lot of argument back and forth, but what cannot be denied is, for whatever reason, global surface temperatures have been dismally below the predictions of the International Panel on Climate Change in just about every climate model that basically writes off the sun and puts emphasis on our carbon emissions. In 2015 and 2016, we had the strongest El Nino ever recorded, and it allowed many people to say, very much rightfully so, that we had the warmest temperatures on record. But what they didn't tell you was that the predictions were for much more than just a few fractions of a degree warming record. They were basically up by more than a degree in their predictions. And that was without an El Nino. So it took the record El Nino to get us their claims of 2015, 2016 being the warmest year ever. But it still didn't even sniff where they thought it was going to be. And we still don't see an end to cold records. We still don't see an end to snow records. In 2009 to 2011, the polar vortex was in position to pound Europe. In 2013 and 2014, the polar vortex was in the position to pound the United States. And the last 2 years, it's been in the position to pound Asia and the Middle East. The last 2 years, for the first time ever, and it's now happened twice in a row, it has dropped below freezing in parts of Taiwan that do not have heating in any part of that area. There's no need for them to have heating. It's a tropical country. They've never needed it before. And it's now been deadly cold twice in a row. Deadly cold has broken records in Afghanistan, in Pakistan, in India. The people in Nepal were experiencing pretty darn cold weather as well, but it wasn't as deadly because they're used to it. Even as far to the west from there as Qatar and Yemen, Saudi Arabia, we've seen snow in the Sahara Desert now twice just this winter that is coming to an end right now in the Northern Hemisphere. Hadn't seen snow there in 40 years. We saw it with 2 separate storms just this winter. And so it's probably going to be moving back over to Europe and then cycling back around. That's sort of what it does. And the question is, what is going on? Because in terms of the more intense tropical cyclone activity, the more intense wind, the stronger storms, and some of the heat days, some of the floods, some of the droughts, some of the extreme flash flood events, all of the other things that they said were going to happen with global warming are happening. It's just that the warming isn't as much as they thought, and it's not without the cold. It's almost like it's just become more extreme with the same amount of energy, so to speak. It's just it swings higher and it swings lower. That's basically what we have been seeing in terms of the global temperatures the last 20 years or so. And specifically, the sun was written off by officials as recently as 2012. That was when the IPCC issued their last written document, their official report, basically writing off the sun in terms of the climate change that we're all concerned about. And since that time, we are now approaching 400 peer-reviewed and published papers talking about how space weather and galactic cosmic rays really do have an influence. And it's everything from the things that had been written off before, reinterpreted, to the things that had never even been considered before, which would be some of the threshold events of space weather and the real role in galactic cosmic rays in modulating cloud cover.
What is a geomagnetic storm? Notable geomagnetic storms in history include the Carrington event, a major storm in 1859 that set fire to telegraph wires and shocked operators. You've mentioned this. You also mention in your book, in early 2016, the BART system in San Francisco encountered 2 mysterious power surges during a geomagnetic storm caused by a coronal hole stream, resulting in major failures. Now, when I read your book, these coronal holes in the sun seem to have quite an impact on Earth. Could you talk a little bit more about coronal holes?
Well, essentially what they are is there are areas where the magnetic fields of the sun don't loop from sun to sun, but they come out of the sun and they reach out and they grab onto something. They stretch all the way out past Pluto unless they connect to one of the planets or an asteroid or a comet or something like that. And it's not like it's a one giant tube. Kind of think of it the way you would. How would I even describe this? If you can picture basically a million strings coming out of a sphere, that would be about how small these magnetic fields would be, and even that is doing it a terrible, terrible disservice. It's just to sort of get you the idea that these things are not huge tubes. They're very, very small. And so right now the Earth probably has, I don't know, dozens, hundreds, maybe thousands of individual connections with these interplanetary magnetic fields back to the sun. And these fields back to the sun connect at coronal holes. They're areas where these things called Alphen waves come out and shoot through the solar system. And since the magnetic fields don't loop back down to the surface of the sun, they stream straight out, they allow the solar wind to stream out much faster as well. And every time a coronal hole faces Earth, a few things happen. For a few days, its strong interplanetary magnetic fields are interacting with our planet, and then it increases the intensity of the solar wind, and that usually can have some disruptive effects on Earth's magnetic field, cause those northern and southern lights, the auroras that I mentioned earlier.
The one solar event that we tend to hear about is the coronal mass ejection. Is this really less significant than some of the other activities of the sun?
Well, it's not that it's less significant. It's a part of the sun's activity. It's resulting from them. And so when there is a solar flare, the energy that comes out as X-rays is one thing. But when I said it can push those particles out, those electromagnetic particles out that hit the Earth as well, that is the CME. It's a coronal mass ejection. It is an ejection of mass from the corona, which is the atmosphere of the sun, usually triggered by a solar flare. And so that would be the other thing that can cause a geomagnetic storm, would be a CME. It's not the actual solar flare itself in most cases that causes the geomagnetic storm. It's the CME triggered by it.
Have there been published studies on space weather and human health? Are there ways to mitigate the risks? What are these health risks, and how would we know when the risks are high?
Well, I will go over to a handy-dandy chart that I have made for discussions just such as this. So if you can envision something I've been talking about, when the sun is not very active, we have these galactic cosmic rays, and that's not good. But when the sun is very, very active and there's a lot of solar flares and these are pounding the Earth, that's not very good either. There's a safe zone kind of in the middle, in an equilibrium. When the sun is sort of active, it's not really hammering Earth too bad, but it's still doing a pretty good job blocking out cosmic rays. That would be your safe zone for human health. And there were dozens of studies done on this in the 50s, 60s, 70s, 80s in Russia, and it's really just starting to hit the ground now in the United States. Essentially, the risks are not that different regardless of whether you're talking about a solar flare, a geomagnetic storm, or a cosmic ray event, because we're all talking about electromagnetic stress on our system. We're talking about acute myocardial infarction, cerebral stroke, heart rate fluctuations, all kinds of heart attacks, including terminal arrhythmia, acute coronary syndrome, increases in blood pressure, basically anything that involves the cardiac system. Over time, these can be factors in degenerative brain disease like dementia and Alzheimer's. This is what NASA is coming out and saying is the result of their studies from astronauts and things like that. Obviously, a lot of people know about the cataract risk and things like that, but not many know about the cancer risk even though it makes sense. It's electromagnetic radiation. And not many folks know about the cardiac risk. Over the short term, psychologically, everything from a flare-up in a psychological disorder to simple cognitive diminution, like you're reading a book or you're sitting in class and everything just kind of goes fuzzy, or you're driving in traffic and all of a sudden you go on autopilot, and maybe you're lucky enough to zone back in and say, whoa, it's a good thing I zoned back in. I haven't really been paying attention the last 10 minutes I've been driving. Things like that. Suicide risk goes up with these things. There's a radiation risk for people on airplanes. There's seizure risk. Migraines go up, especially during geomagnetic storms and solar flares, not as much during cosmic ray events. Flare-ups in everything, digestive disorders, skin conditions that are subject to flare-ups. Those kind of things can follow some solar flare events. It's the kind of thing that has really broken open and really found its ground and is being studied on a number of different levels. And luckily, just as it was hitting the ground in the United States, this was back in 2002, and then another one followed in 2008. Some fantastic literature reviews surveyed all of the old Russian work and really basically let U.S. researchers start much above the ground level when they began running with this. It's for the same reason that the sun can affect earthquakes and galactic cosmic rays can affect volcanoes. These things can affect our technology, and these things can affect our bodies because, believe it or not, our bodies are very, very much electric. When you get down to the cellular level, almost everything is electric or polarity. It's as important, if not more important, than the organic chemistry itself. What elements are there? What molecules are there? And that's why this works. Now, in terms of how, the last part of your question, how do we know if these things are going on? Well, you can keep an eye on space weather all the time. It sounds like it's difficult. It's really not that difficult. We have websites that let you do this. In the morning news show that we put out every day, we discuss exactly what space weather is doing, whether or not there's any geomagnetic storms or cosmic ray alerts. And we also have the Disaster Prediction app, which is now officially the fastest geomagnetic storm notifier, faster than both NASA's top physicist and the official government alerts from NOAA. The fastest geomagnetic storm alerts in any app in the world. It also beats their email alerts. And that's also where we issue our cosmic ray health alerts. And those do not exist anywhere else in the world except for our app.
I'm speaking with independent researcher and author Ben Davidson. Today's show, Space Weather and Earthquakes. I'm Bonnie Faulkner. This is Guns and Butter. How would a person get your disaster prediction application?
Well, unfortunately, if they have a Windows phone, they're a little bit out of luck. It is available on Apple and Android only right now, and it is called the Disaster Prediction App. It is by Space Weather News. If you have trouble finding it on your app store, you can just go to spaceweathernews.com, and there's a button for the Google store page and the Apple store page. Of course, it would be helpful to do that on your phone, so you actually, get to the iTunes page where you're going to use it, or your iPad. It works on the iPad as well. But truly, if you take that 1 hour I mentioned earlier, and you click "What is space weather?" up at the top of spaceweathernews.com, you'll be able to just use the free website, spaceweathernews.com, anytime you want to look. Now, granted, it might slip your mind. You might not watch for a couple of days. If you would want, the kind of thing where you want to be notified when something is happening and you don't want to be bothered with learning about the physics and going and checking the website every day to make sure that you're not under some kind of health alert. Okay, the app costs $3 and it's well worth it because it's not just that, but it's where our earthquake risk maps are posted as well. We haven't even talked about that, have we?
Well, that was my very next question, Ben, and that's a very important one. You just launched the Earthquake Prediction Center. What is it, and what do you hope to do with it? How successful have you been at predicting earthquakes?
Here's the short version of the story. So in 2015, I thought I noticed a pattern between the sun and large earthquakes. I went to a NASA engineer, and he noticed the pattern too, and he thought he could explain it. We went to a statistics professor from The Ohio State University to say, hey, can you prove that this actually is a pattern and we're not crazy? We think we can explain it if it's real, but we'd like to know if it's real first. And he agreed to the point where he put his name on the peer-reviewed paper with us. That really led us down the line to really where we are today, which is not absolute earthquake alerts like hurricane forecasts are, but of the total global fault system where an earthquake could happen pretty much anywhere at any time. We know chances are if one's going to happen, it'll probably be in the Ring of Fire, but we still probably get 25 to 40% of the big earthquakes every year outside of that area. So it's sort of a crapshoot, and at the moment there is no official recognized pattern to earthquakes, except that since October 15th, 2016, that would be just this last fall, when the full current model went into real-world, real-time operation, and in the practice period before that as well. That global fault area can be reduced to between 10 to 20% of itself. So we're talking about tiny areas. Sometimes that 10 to 20% is, one coastline of a continent, like Chile, Peru, and Ecuador. Or sometimes it's broken up into, maybe just a few 100-kilometer segments in a couple of different places. But that 10 to 20% is capturing more than 80% of the magnitude 6 and higher earthquakes. And that's really when things, start to get dangerous. That's when buildings come down. That's when people die. And when you get much larger than that, that's when tsunamis occur. And so since October 15th, 2016, there have been 30 of those events that are magnitude 6 and higher, above 6.0 baseline, that are also considered significant because they are close enough to the crust to be felt. If we get a 6.2 and it's 100 kilometers down, it's maybe not as significant. And so there have been 30 of those real significant events, the 30 big ones since last October. 24 of those have hit our high alert zones, and those high alert zones have averaged 17.9%. So on average, we're putting about 17.9% of the globe on alert, but we're getting about 80 to 83% of the biggest earthquakes.
What are some of the recent earthquakes that your Earthquake Prediction Center has been able to predict?
Well, on October 29th, the only time our highest alert, which we call an alert star, we put a giant star on the map over the area, the only time an alert star of ours has ever appeared outside of the Ring of Fire, only happened once, was October 29th, 2016, and it was over the country of Italy. Many people know that on October 30th, just one day later, a 6.6 struck that area. It took down the Basilica of St. Benedict, and it was the largest earthquake that has hit there in decades and decades. The only 6-pointer that has hit the United States during this period was a 6.6 that struck on December 8th. The United States will get what we would refer to as a yellow alert or an orange alert every once in a while. That's not wholly uncommon, but a red alert in the United States is very uncommon. But the red alert in the United States began December 6th, was confirmed December 7th, and the morning of December 8th, a few hours before the 6.6 did end up striking the Mendocino Junction offshore of California. Luckily, that one was offshore and a few kilometers deep, plus the ocean. And so that one was felt by some people in the Golden Triangle, but there wasn't really any damage. There have been no 8-pointers since the model began running. However, there have been a number of very large quakes, and for those who are looking to get more information on this, they can go to quakewatch.net, and at the bottom of the page, the left button is the model, stats and information. Essentially, there have been 2 7.9s, 2 7.8s, a 7.6, and a 7.3, and that's all. There have been 6 7-pointers since the model began. Only one of them was not in the alert zone. Both 7.9s struck Papua New Guinea. They were in the alert zone. The 7.8 that caused a tsunami in New Zealand, it's being called the most complex earthquake in modern history. That one was also in an alert zone. There was a 7.8 that struck the Solomon Islands that missed an alert zone by a few hundred kilometers. I know that's very close, but when it's out, it's out. One hit Chile and one hit the Philippines as well. Basically, everywhere except the Middle East, we have had success with this. Every 6-pointer that has struck Japan since October 15th has struck an alert zone. Every single 6-pointer that has struck Chile, Argentina, or Bolivia has hit the alert zone. We had the only one that struck the Middle East was a 6.6 in Tajikistan. And actually, I'm sorry, there was one other one in Pakistan that we did get, so we have had success there. But the biggest one was in Tajikistan, a 6.6, and we took the region off alert 72 minutes before the event happened. We learned some harsh lessons that day, removing a red line in the middle of the desert in the Middle East. And then about an hour later, they get a 6.6. We really felt bad about that one. But we also felt we learned a lot from that as well. We do, unfortunately, end up needing to fail in order to make progress and learn, which with people's lives at risk, that's a tough pill to swallow sometimes.
There was a significant earthquake several years ago in Nepal. I don't remember the year. Are you aware of that earthquake? And was your app up and running then?
Oh, it was not. The app went into operation on December 20th, just last year, and so literally the model began running before the app did, and so the model has been available for people on Twitter and on the website for people to see, but now it posts first to the app. And then I take screenshots of the app and I repost those on Twitter for people. But the actual model and links to all of the publicly time-stamped by Twitter and preserved forecasts is on quakewatch.net as well. Those links are all still active. They've all still got their Twitter timestamps, so you can see when that map was posted, and then you can go see when the earthquake occurred and see, hey, yep, the times match up. No funny business there. That's something really important that forecasters don't always do. They don't always give people a way to verify what they've done. And I have found difficulty getting through to academia due to my use of Twitter, but it's publicly time-stamped. It's not like Twitter can be hacked and you can go in and change things. And with 18,000 followers, people are retweeting everything. Even if I delete something, the record of what I've done is there. People are retweeting it all the time. And I don't know if you know this, but just because you delete a tweet, it doesn't delete the retweets and the other things like that. So I thought Twitter was perfect because you can't cheat. It was likely to be seen with tens of thousands of people. But as you might imagine, university professors and government folks weren't really looking at Twitter and thinking much of it. So the model has really just started, just this fall. The first official presentation of the model hasn't even occurred yet. It will occur April 8th and 9th at a conference called Observing the Frontier. It's going to be in Albuquerque, New Mexico. It is sold out. It's been sold out for a while, but they're going to be recording the presentations and putting the audio to the slides and the PowerPoints and everything else that is being shown. So that will be hitting the public airwaves soon. The goal is not to patent this. The goal is not to try to get through to academia. I did everything I could for as long as I could, and their stubbornness has about met my own. So I've decided that the better thing to do, since people who watch my show, people who just spend a few minutes on the websites, they start predicting earthquakes themselves. Since a kid got a scholarship to his top choice university after writing an essay on this topic, since I got a 12-year-old to predict 4 6-pointers in a row, I think I can teach just about anybody to do this. And the goal is, we've got QuakeWatch.net, we've got the app, and the tools to teach and allow you to do this in real time are starting to be put there. If you go to QuakeWatch.net/prediction center, you're going to find the first tool is actually already up in there. It combines our number 1 subterranean signal with our number 1 atmospheric signal. And the earthquakes we're looking for happen in between those two. We don't want to go through it. There's a pretty good explanation on the site. But the idea is to share that presentation that's happening at that conference publicly, and then continue just dumping information every time I figure something out or somebody figures something out. Just keep dumping that information to the point where before we know it, we've got thousands of people being able to predict the next earthquake. And before too long, we are going to have a very good grasp on what's going to happen when and where. Because so far, it's really just been in my hands and the hands of the folks who are, the most diligent observers of what I do, and the folks who take the time to go to the websites and really dig in a bit deeper. The moment this gets truly open source and, people can pick it up and improve it like the way open source was meant to be, I'll be more than happy to sit back in a rocking chair and watch the world start really giving warnings to people before these deadly seismic events occur.
I'm speaking with independent researcher and author Ben Davidson. Today's show, Space Weather and Earthquakes. I'm Bonnie Faulkner. This is Guns and Butter. Could you talk about how the sun triggers large earthquakes?
Well, absolutely. We have this constant electric interaction between the Earth and the sun. And when people are looking for a connection between the Earth and sun, they're always either looking for sunspots, or they're looking at the solar wind, or they're looking at solar flares, or they're looking at those geomagnetic storms. And what they fail to realize is that those things aren't going to be the things that are going to be primary in earthquake triggering, because those are small scale by comparison to the interplanetary magnetic fields of coronal holes. I mean, the smallest coronal hole dwarfs the largest sunspot. The interplanetary magnetic fields from coronal holes will literally grab onto a planet and create a direct plasma exchanging connection between that planet and the sun. It's the only thing that gets to bypass Earth's magnetic field. The solar flares, the cosmic rays, the solar wind, all of those things have to contend with Earth's magnetic field. And yeah, sometimes they're able to disrupt it and cause a geomagnetic storm. But the interplanetary magnetic field does not have to worry about Earth's shield. It is a direct connection. And when you think about how much metal, how much crystal, how much water, I don't know if you heard about this, but there is more than the entire Earth's ocean's worth of water trapped beneath the ground that we can't see. All of these things are conductive. They're subject to magnetism. They're subject to electric currents. And, whether that's iron, whether that's olivine, whether that's crystals, water, we're talking about a direct magnetic connection on large scales, the kind that can move continents, the kind that can move plates. And the way it does this is by electricity. The same thing that we mentioned before. This is very hard to do if you don't, if you can't visualize it. But the electricity on Earth, we think of it as just the lightning. But the lightning is sort of just a static discharge, like whenever you get shocked because you've dragged your socks on the carpet and you touched the metal door handle. That's not really a system, that's not really a flow, but that flow does indeed exist on Earth. In fair weather, high pressure, clear skies, the currents come down to the ground. They go back up in storms. Sometimes those currents won't make it to the ground. Sometimes they'll hit ambient clouds, juice them up. Sometimes, when they come down to the ground, they won't be encountering the surface tension of the ocean or the telluric currents of the crust, but they'll be encountering a fault line, in which case, path of least resistance says, let's go deep. We have aligned layers of crystals. Well, crystals are not going to let current pass, so it's going to sort of funnel it sideways around. Well, where are the storms? Because that's where we might look for that energy to come back up out of the Earth. We know it's got to get back up to the top of the sky anyway. We know it can only get there through the storms. Well, okay, what path is that going to take from the high pressure to the low pressure? And so what we can do is, and this was the case with the call on the California earthquake, the day before that event happened, I should say the morning that event happened, we had described how the other red alert that day, sitting in the middle of China, had got struck by a 6.0 because it was facing the sun when a coronal whole solar wind stream arrived. And we had said that if there is another stream, and it happens to be when the United States is facing the sun, then we might have to be concerned, especially because there was a low-pressure system, a storm, a good solid one, right off the Mendocino Junction. The incoming solar energy from the solar wind was coming directly down onto the United States, and there was a massive high-pressure cell over most of the country, so high pressure, from sky to the ground. And it was clear that the sister system to that high pressure cell was the low that was off of California. And so we have this introduction, this pushing of Earth's magnetic field, the Van Allen belts, and the global electric circuit, increasing the energy down onto the Earth that day, down onto the United States that day. Now, for the 3 days previous to that, we had seen increasingly strong earthquakes migrating from inland California towards that storm that was sitting offshore. The last of those foreshocks actually was offshore, near where the 6.6 ended up happening, and was triggered as the next solar wind stream hit Earth. Within an hour, the 6.6 came out basically where the storm was. It was a perfect solar system circuit event where we saw energy from the sun slam the Earth, and twice in a row. It was sort of a double stream. It hit once during the daylight in China and hit once during the daylight in the United States. And both times, we saw that energy come in high pressure. We saw foreshocks build towards a low pressure, and we saw big earthquakes occur towards those low pressure systems. Luckily in China, nobody lives where that one happened. In the United States, some people felt it, but didn't cause any damage. That's the kind of thing I love to see, when we can get a perfect example of the sun influencing Earth's own electrical system, and nobody dies, and not a building is, has a crack in its wall or its foundation or something like that. Those are the days I live for.
With regard to your upcoming conference in early April, Observing the Frontier in Albuquerque, New Mexico, who are some of your speakers?
Well, we are proud to once again have Dr. Pierre-Marie Robitaille of The Ohio State University. He is not the statistics professor that we went to there, but he is one of the top folks in their radiology department. And if his name is sounding familiar to anyone, it might be because modern MRI machines are what they are because of him. If you've had something that a doctor found because of an MRI, or maybe surgery to repair a knee or a shoulder went well because the doctor knew exactly what he was looking for when he went in there, we can thank Dr. Robitaille. And that goes to any tumors or anything else found in an MRI or anything like that. Essentially, when he wanted to put 8 Tesla magnets into MRI machines, they said, "You're going to fry people's brains." And he said, "No, I'm not, and here's why." And he proved that he was correct, and now this is how MRIs work. Well, what do you do apart from just sort of sit back, have your position at the university, when you've basically rewritten a piece of physics? You take a look at what else that incorrect piece of physics has been applied to. And it turns out that that incorrect piece of physics that he fixed to get us to the MRI machine that we have today is what is necessary to think the sun is a gas instead of a liquid, to think the microwave background is a signature of the Big Bang, and a number of other fundamental cosmological things just like that. And he is going to be talking about the nature of stars and the nature of water, which we are very, very excited about. Dr. Michael Claridge is a member of the Sapphire Project and a frequent contributor to the Thunderbolts projects. He is going to be giving 2 presentations. One is going to be much more of his standard electromagnetic physics type presentations, and the other, we do expect a Sapphire update, their attempts to create the electric sun. So that'll be fun. Eugene Bagashoff is coming, and he's going to be talking about magnetic vorticity. I really hope that has to do with tornadoes, because I think that could be really, really interesting, although I'm not entirely sure what he's going to talk about. I've got Dave Talbot from the Thunderbolts Project. We're going to be doing a live interview, and I'm going to be asking him some very difficult questions. I'm not going to surprise him. He knows what's coming, but not easy questions to answer. And Adrian D'Amico from the Suspect Sky YouTube channel and I are going to be doing that as well on topics that are more his realm. Tony Rango is going to be there giving an electric geology report. Really couldn't be prouder of Tony for attempting to fill this gaping chasm of a void filled when Michael Steinbacher left us last year. Really almost no way to describe how big of a hit that was to the electric terraforming and the electric geology world. And Tony, thankfully, is going to continue his efforts in bringing that back, keeping it alive, etc. I will be giving a number of talks as well, although it's really just one presentation. Broken up into 3 different segments. One is the results of the earthquake forecasting. 2 is why it works and how it works. And 3 is really teaching folks how to go out there and do this themselves.
You do a short show every single morning, 6 a.m. Eastern. Are those daily shows archived?
Absolutely. Absolutely. All of those shows are archived. Every morning since 2011, we have put out a 5 to 6 minute update on what the sun is doing, how it's affecting the weather, earthquakes. Sometimes we'll throw in some interesting space news if it's there to be had as well. Those can all be found on YouTube, and a specific archive of them can be found on spaceweathernews.com as well. In the menu bar, just click Solar News Archive. Or Solar Archive, I think it says.
Ben Davidson, thank you so much again.
Absolutely. It was my pleasure.
Good luck at Observing the Frontier.
Thank you very much.
There's something happening, yeah. What it is ain't
I've been speaking with Ben Davidson. Today's show has been Space Weather and Earthquakes. Ben Davidson is an independent researcher into the science of climate change. Be sure to tune in next week when Ben Davidson will spend the hour discussing magnetic pole reversals on both the Earth and the Sun. He will talk about the effects of two things that are coming together to create increased cloud cover, which will decrease temperatures and debunk the greenhouse effect. He will also discuss how the melting of the poles is actually one of the triggers of an ice age. Visit his websites at suspiciousobservers.org. That's suspiciousobservers.org with a 0 instead of the letter O. Also visit earthchanges.org and spaceweathernews.com. Follow Ben Davidson on Twitter at TheRealSOS. That's TheRealSOS. Guns and Butter is produced by Bonnie Faulkner, Yaramako, and Tony Rango. Visit us at gunsandbutter.org to listen to past programs, comment on shows, or join our email list to receive our newsletter that includes recent shows and updates. Email us at faulkner@gunsandbutter.org. Follow us on Twitter at G&B Radio.
Hey, yo!